Welcome to today's Fix It Friday, and this week we are looking at bond angles and shapes of molecules. So this question has told us the formula of the molecule NCl3, and it's actually told us the bond angle, which gives us a lot of clues to the shape, and then wants the name of the shape and an explanation for the bond angle. So there are two really major errors in this written description. The first one, hopefully, is easy to spot, and that is in the shape, because planar means flat. If something had three parts and it was a flat shape, then those three atoms would be 120 degrees apart. So this is not a flat shape. This is not trigonal planar, it's trigonal pyramidal. And actually, you don't need the word trigonal in this case because there is only one type of pyramidal shape. You may want to remember it though, because the slightly unusual five-membered shape is trigonal bipyramidal. So kind of if you're getting that word trigonal in there every time, it might help you remember it for that shape. So the lone pair, this is the next awful error. It says the lone pair repels the chlorine atoms. Oh, that's terrible. So it's not repelling atoms, it's repelling other sets of electrons or other areas of negative charge. So, and after that, the other real thing about this is it's missing most of the details that you need in a shapes of molecule question. Shapes of molecule questions are often worth 3 to 4 marks, and therefore we want to get really clear on some clear steps that we can use in our explanation when we're writing about it. So we don't want to talk about repulsion yet. First thing we want to talk about is how many areas of electrons are there around the central atom. In this case, we're calling them areas, not pairs. They are pairs because they're all single bonds or lone pairs. But just remember that a double bond is an area of electrons that sort of has to move as one piece, but it's not a pair, it's 4 electrons. So it might be better to use areas or sets of electrons. So I'm going to say that there are 4 areas of electrons around the nitrogen. So I'm also talking about the central atom because that's the only one that is relevant to the shape. After that, we're going to say what those areas of electrons are made of, because that's obviously important when we talk about angles changing and lone pair effects. So there is 1 lone pair and 3 bonds, or 3 bonded pairs if you wanted to. Of course, like if it was double bonds, it's easier just to say bonds rather than bonded pairs. So that's my first point. The next point is one that seems to be quite commonly mixed, because you seem to kind of want to jump to the next bit about lone pairs and how they repel. It seems to be something that sticks in people's mind quite a lot. But we need to actually say like why molecules have any shape in the first place before we talk about the shape changing and the angle reducing. So the molecule has the shape because electrons repel each other and therefore they move as far apart as possible. So electrons repel. I'm not actually going to say that they move as far apart as possible. I'm going to rephrase it slightly differently. And so I'm going to say they move apart to minimize repulsion. And why I like that phrase is because if you say as far apart as possible, but then you say it's 107 degrees, that isn't as far apart as possible. As far apart as possible is 109.5. So you're establishing that there's other things going on, and actually the angle that they get to is the best angle they can get to get the least repulsion. So electrons repel, or even better if you'd said areas of electrons repel. They move apart to minimize repulsion. So we're going to say what it's based on, because there are 4 areas of electron. It's based on a tetrahedral shape, and that has a bond angle of 109.5 degrees. And now and only now have you really set yourself up to clearly talk about the reduction in the bond angle. So now we can say that lone pairs repel more than bonded pairs because of the extra electron density in a lone pair, because it's not being shared with another atom. So lone pairs repel more than bonding pairs, so the angle is reduced to 107 degrees and a trigonal pyramidal shape. Don't forget to pop the shape on the end. If you think you're going to forget the shape, put it at the start, because then you know where you are. So this framework can be used to answer any shape of molecule question. You need to get to counting the areas of electrons first. You need to establish how many lone pairs and how many bonds, and a double bond counts as just one area in terms of bonds. This phrase about electrons repelling and moving apart to minimize repulsion can be used in any question about any molecule or ion ever. And also you want to talk about what the shape was originally based on. Now, of course, if there are no lone pairs, then it will just be whatever the shape is, because if it's all bonds, we don't then need to continue talking about lone pairs repelling more than bonded pairs. So if you want to know more and brush up on some more of your A-level chemistry, I've got some free Quizlet flashcards which include things like these descriptions of electron pair repulsion theory, link in my bio on Instagram. A-level masterclasses are starting in March, and there's a link in my bio there. Those are really limited in places, and you get loads of materials and loads of support in small group online classes. So have a look into those if you're wanting either in year 12 to brush up on for your mock exams, or if you're in year 13 and you're preparing for the real thing. I've got classes suitable for both levels. And there are some practice exam style questions, all with explainer videos and some tutorial videos on my website, ckchemistry.co.uk. Follow me on Instagram, Facebook, more A-level chemistry tips, revision materials. I've also got an A-level chemistry revision planner coming out soon for those of you that are taking exams in the summer.